Welcome to Mr. Yee's tutorial on the Hardey-Weinberg practice problems. You should have your homework sheet in front of you, and I'm going to go through the problems on the paper. But first, before I start, I will go over the two equations that you should know for the Hardey-Weinberg, and that is going to be the P plus Q equals 1, and the P squared plus 2PQ plus Q squared equals 1. And if you remember from class, over here, these are talking about the alleles themselves, the frequencies of a dominant and a recessive. And over here, it is talking about the types. So the heterozygous and the and you got the homozygous over here. It could either be homozygous dominant, heterozygous, or homozygous recessive. Okay, so let's go ahead and take a look at number 1 on your sheet. So number 1 gives you some information, and it tells you the allele frequencies offhand. So it says that A equals 0.9, and excuse me, that should be a big A. So let's erase that. Okay, big A and little a is going to be 0.1. Now, if you remember in our Hardey-Weinberg equation, P is going to be for the dominant allele, so this is already P, and Q is going to be the recessive allele, which is the little a. So immediately, we already know what the P and Q is going to be. So P is going to equal 0.9, Q is going to equal 0.1. Okay. Now, the question goes on to determine the frequencies of 3 genotypes. Okay, so that goes back to the heterozygous and homozygous. So our equation for the 3 genotypes, big A, that's our P squared. So that means we will take 0.9, square it, and we will get 0.81. Our next one is going to be big A, little a, which is our 2PQ, which equals 2 times 0.9 times 0.1, which would equals 0.18. Okay, and then I'll do the last one for you, which is the 2 little a's. That is Q squared. So that gives us 0.01. Okay? So your answers are going to be asking you these right here. Okay? So this is your answers for the problem. Okay, going on to number 2. In number 2, it's asking you again, what is the frequency of the Z allele? Okay, the Z allele is a recessive, so that means that is going to be Q, which is 0.6. Now we can automatically figure out what P is, because P is going to be 0.4. How did I figure that out? Well, in our equation, P plus Q equals 1. So we already know what Q is. And it's just a matter of finding the missing variable. So P must equal 0.4. Okay. Now, it's only asking you for one, the heterozygous. So the heterozygous is 2PQ equals 2 times 0.4, 0.6, which then will give us 0.48. Okay, so that there is your answer. Going off to number 3, excuse me, not the 3, number 1, under recessive traits. Right now, they are talking about a chemical called PTC, and we probably talked about this in class. And what you want to look for is something about the recessives. Now, the recessives are the ones who cannot taste it, and it looks like that's going to be 30% of the people. Okay, did not say that Q equals 0.3 because it's a percentage. It is a proportion. It is a statistical number. So saying that means we are talking about Q squared. We're talking about the the homozygous recessives. Okay, so this is going to be 0.30. And then we can solve what Q is by taking the square root of 0.3, which will give us 0.55. And then we can figure out what P is, which is 0.45. Okay. Now the question is asking us to figure out what is the homozygous dominant, homozygous recessive, heterozygous. Well, we've already figured out what the homozygous recessive is. We can easily figure out what the homozygous dominant is, which is going to be P squared. So P squared will give us 0.20. Last thing is the heterozygosis. So again, heterozygosis are represented by 2PQ, 2 times P times Q, and that gives us the answer of 0.50. So our answer for the problem is here: homozygous recessives, homozygous dominants, and the heterozygosis. Problem number 2. Here it gives you a statistic of how many are born with cystic fibrosis, and it has a series of questions A, B, and C. So to figure this out, we will start out with A. What percentage of the adult population has cystic fibrosis? Okay, so it gives you a statistics, 1 out of 1,700. So to change this into a percentage, we divide it and then multiply by 100, and that will give us 0.06%. Okay. And B, calculate the frequency of the two alleles. Okay, so we have to figure out what the P's and the Q's are. So we already know what Q is. Q squared equals 0.0006. Okay, we found that out from our information above, and we can easily figure out what Q is by taking the square root, which is 0.2. Okay, remember this is going to be the little c. P is going to be just 0.98, and that's going to be the big C. Okay. Now down to part C. Part C says calculate the frequencies of the two big C's and big C and little c. Okay. So what part of the equation does big C represent? That would be P squared. Okay. So above we figured out what P squared was. Excuse me, we figured out what P was, which was 0.98. So we just multiply 0.098. We square that, and we get up to a number of 0.96. Okay. And then the other part is we need to figure out what the big C, little c is. And remember that is the heterozygous. So 2 times 0.98 times 0.02 was 0.04. Okay. So here is your answers for this particular section on the problems. Going on to D, the last part. How many of the 1,700 members are normal big C, little c? Well, that's easy. We're just going to take the population total and multiply it by the frequencies that we found. So big C, well, that is our P squared again, right? So all we need to do is take 0.96, multiply it by our population number that they gave us, and we get 1,666 people are going to have big C, normal. The other one, big C, little c, carriers, that's our heterozygosis. So we only take 0.04 multiplied by 1,700, which will give us 68. Okay, so Here's our answers for this section: 1,666 people and 68 people. Now on to the last question of the day, and that is going to be question number 3 on the back side of your paper. So question number 3, and there's a couple sections here. So we'll start with A. We're talking about a population that has a RH negative factor. And again, RH is referring to the blood type, where you're positive or negative. And is asking us to figure out the frequency of the recessive alleles. Okay, so 16% of the population has RH negative. Okay, so what is going to be the frequency for them? Well, Q squared equals 0.16. And we just change that percentage into a decimal. And then we go ahead and take the Q, square root, we get 0.40. And for B, what's the frequency of the dominant allele? Well, since we figured out what Q is, we can figure out what P is. Okay, and then finally C, we have what the percentage of homozygous dominance and heterozygous in population. Okay, homozygous dominance again are P squares, so that is going to equal 0.60 squared. Percent will equal to 0.36, and the heterozygous are 2PQ, so that will give us 2 times 0.60 times Q, which is then going to give us a grand total of 0.48. So these are the answers to your homework. Make sure you do correct them and be ready to be coming into class to be probably doing more practice problems. So I hope this was going to help you, and I'll see you later.